Good morning, Dr. Tana. Okay, little by little, we are getting more closer to this structured essay, and then we can done with the organic chemistry. Just I want to know your opinion. If you guys are in really good shape, I don't have to explain everything like okay. Yeah. Okay. I know too much instructions are not necessary if you guys are in good shape. Okay, I'm going to start from the attitude about organic, only organic. Just whatever you feel. Yeah, somewhat okay. Just can you make sure that you're going to be not the better, like the best when we're done organic? So you have the confidence. Okay, so you have the confidence and you feel like now you know organic chemistry. And now, yeah, okay. You feel getting better, and do you have the confidence that once we done organic chemistry, I wouldn't have any sort of issue? How is inorganic? Memorizing. Otherwise, the questions, answering questions, challenging everything, those are pretty much okay. Nadija, how do you feel about organic chemistry? Now, okay. Inorganic, yeah. What kind of issues you feel like? What are the challenges? Only the memory. Analytical part calculations are okay. As long as answering questions are okay. Memory is nothing. You just need to go through, like I told you guys, organic is easier. So every week when you are doing organic still, go with inorganic. And last week I've given you guys these special instructions how you're going to go through the rest of this time. Either you can say like this. So you are hanging on a tree. This is a tree branch. These are your hands. You are hanging on a tree. And you have done there huge like drench and fire and everything. Would you ever give up? No. You would hang as much as possible. Like that. Hang in here. Have the strength. Have the determination. Go through this. I have this new target. I'm going to bring these Ratnapura students to higher self-assessment, 4 Ratnapura students. You guys, I mean, all these 4-year students showed me that I can do that. I'm going to bring all of you about this district quota. Like, I want you guys to be like merits. Merits mean first 800 students. You can do this because I have done this for past students. So work like hell for all these 3 subjects, thinking only of your future. Whenever you are doing physics, you are only thinking about how would I reach 100 marks for physics. When you are doing biology, only think about biology. How would I do my best to reach 100 marks for biology? And in 2019 or 2020, they were reaching almost 100 because marking scheme was little losing because they had lots of issues. So still that challenge is there, but it's really hard to go to 100 marks for biology. But there's this saying, if you want to reach the moon, at least you have to, sorry, if you need to cling onto a wall, you have to try to reach the moon. Like wall එකකට නගින්න ඕන නම් target කරන moon එක. So that saying is there. So target that. And let's say it's maths, just target 100 marks and trust yourself you can do this. You can do this because I have done this with, it's not how much you have talents, it's how much you have effort. Best example is 2021. There were very, very poor students that even school teachers were discussing. Once those students went to school and once they say their results, once they left. So then other students were hearing, school teachers are discussing about these kids. I did that. I can do that. Just go through this path, okay? All right. Have the energy. If you lose, that's because you are losing yourself. If you couldn't get good results, it simply means you have given up. Don't give up, just hang in. All right, I'm going to start. We're going to start from organic, question number 184. Okay, acidic strength. I would just ask, refer the short note. Is there anybody who's having issues with short note? Is there anybody who's not referring the short note? Okay, rather than writing everything here, if you write here refer short note, I would like it because when you go through the short note, you are reading from the beginning to the end. Weakest acidic to strongest acidic, you are taking from the short note. So just go like that. Anyway, I just explained the answer. Some sort of acid is here because oxygen is electron negative. So it takes up OH bond electrons. But you have inductive effect coming from CH3 group, so that less acidic comparing to water. Water doesn't have inductive effect, so the acidity is greater. But with this, other than oxygen's electronegativity, benzene ring is again dragging electrons into it. So oxygen's electronegativity increasing more and more. So releasing hydrogen as H plus become more easier. But coming to carboxylic acid, dragging electrons away from two oxygens. So releasing H plus leaving electrons become more easier. Question number 184. If you want, you feel like you want to write, you can write this. It's up to you. Question number 184, answer 4. Question number 185. Again, acidic strength. D, this is providing electrons, less acidic. A, normal phenol, normal acidity. These two are dragging electrons away, more acidic. This is providing electrons to ortho and para positions. So that when NO2 is joining onto ortho or para positions, then it can drag more and more electrons away so that the C has the highest acidity. Question number 185, answer 1. Let me read this. If you write or not, it's up to you. This is the phenoxide ion. This shows resonance stability by delocalizing lone pair of electrons on oxygen with benzene ring. Therefore, phenol is acidic. NO2, strong ring deactivated, drags electrons away from benzene ring, increases acidity. Since hydroxyl increases electron density of oxygen, ortho and para positions, NO2 can hold electrons easily when attached to ortho and para positions compared to metal. So these are the answers of structured essay and essay when they are asking, explain the answer. Okay, if you feel like you want to write, you can write. That's really all right. Question number 186. Consider two reactions of phenol given below. This is acid halide. But the thing here with this, there are two different reactions. Either it can go esterification or otherwise Friedel-Crafts acylation. But for Friedel-Crafts acylation, this is supposed to need this catalyst, no catalyst. So it is going through the esterification. Only this phenol can esterify with acid halides. No external driving force needed since chlorine is a good leaving group. Phenol esterifies only with acid halides. Okay, so this is the A. Then the other side, basic medium, this chlorine gets away with this hydrogen here. So this is the product, orange color dye. So that is B. 186, answer 3. $187. Just say this one. If you had anhydrous aluminum chloride, it is going through a Friedel-Crafts acylation. Question number 187. Phenol is an aromatic compound. Yeah. Ethanol is not. The statement is correct. The stability of the phenate ion relative to phenol is greater. This stability is greater comparing to this. That's why this has higher acidity and this has this resonance stability, negative charge delocalizing in the benzene ring. That part is correct. Then the stability of ethoxide ion relative to ethanol. Yeah, this exists this way. But if you go with this condition, this is more stable. So that's why it is existing in the medium. That's why it's not releasing that much H plus to the medium. Okay, this is this condition. The second statement is true. That is not the reason that phenol is aromatic and ethanol is aliphatic. So no explanation. 187 answer. Question number 188. Wrong statement is asking. Now we are moving on to reactions. Amides are less basic than ammonia. Yeah, ammonia directly can produce its two lone pair, but amides with this resonance stability, so you get a plus charge on nitrogen. Now no lone pair, so the less basic. Phenol readily reacts with formaldehyde in the alkaline medium, both acidic and alkaline. Just write there question number 182. 182 last week we did the bakelite. So here they are talking about that. So 2 is correct. Phenols are more acidic than alcohols. That's from last question. We explained that from 187. That's true. Boiling point of carboxylic acids are higher than aldehydes with same molar masses. That's because of carboxylic acids are making hydrogen bonds. Aldehydes are making only dipole-dipole interactions. Phenol readily undergoes electrophilic substitution reaction with Br2H2O to give a white precipitate. It's not addition. That's why it's wrong. 188, answer 4. Question number 189. Colombo class is going same way. Those students are not writing things, all are coming with answers. So they are just checking their answers. You and them are same compatibilities there. Even the single medium students, they are not writing anything. They just wait until I explain things just to check their answers. Let's go like this for equilibrium as well. So we can finish this soon and we can start with paper. Reactions of phenol. Okay, A, bromine esters, and this is the answer. That's again, they are asking this, see, this time, they were not given this compound. They were only given the ethanol chloride name, acid halide. 189, answer 5. Question number 190. Phenol readily reacts with bromine water to give white precipitate. Yeah, this is a white precipitate. Bromine adds to compounds containing double bonds. They are not talking about the additions. They say you are just adding. You are adding bromine to compounds with double bonds. But when you are having a double bond, the reaction is definitely compounds containing double bonds. So the reaction definitely is electrophilic addition. Double bond means addition. But this is substitution. So no explanation. 190, answer 2. No explanation. 190, answer 2. $191. Which one of the following statements is true regarding phenol? Phenol reacts readily with formaldehyde in acidic or basic medium, making bakelite. 182. Phenol is less acidic than ethanol. Question 187. Yeah. Sorry, wrong. Phenol is more acidic. Phenol reacts with, no. Phenol, not phenol. Only with sodium and sodium hydroxide, phenol reacts with. Substitution reaction to give this tribromo compound. 191, A, B correct. Answer 4. Moving on to carbonate compounds. Question number 192. The compound Q is insoluble in aqueous sodium hydroxide. Okay, so no acidic parts, or maybe we can say that there are no alpha hydrogen, but I'm just suspending with that, okay? Anyway, it gives a orange precipitate with Brady's, so it's supposed to have carbonyl. Ammonical solution of silver nitrate. Ammonical silver nitrate means tolerance. Carbonyl mean aldehydes and ketones. Tolerance mean aldehydes. So even you have it gives an orange precipitate with Brady. Q reduces to ammonical silver nitrate of Q reduces means it's supposed to have CH2 as well. The organic product obtained again giving this orange color. So this is supposed to have both aldehyde and ketone. because once we oxidize the aldehyde part, still it is giving Brady, because if you oxidize CHO, it is oxidizing up to COOH. So if you had only aldehydes, it cannot go through second oxidation with Brady if it doesn't have its own ketone. Okay, this cannot oxidize further. As they say, this one not oxidizing. This is reacting with sodium hydroxide. And this is again COOH is possible. This again has COOH. This again has ester part. Okay, number 1. And also no reaction with tolerance. And COOH, insoluble in sodium hydroxide. Not insoluble, this is soluble in sodium hydroxide. Then these are COOH, sorry, these two are. These two has this ester, so that NaOH soluble. This again is sodium hydroxide soluble. This is again soluble, okay, not insoluble. We have only possible answer as 4. 192, answer 4. Question number 193, Anu, can you which of the following reagents could be used to distinguish chemically? Okay, both are aldehydes. Only difference is both are aliphatic. Only difference is this has long carbon chain. This doesn't have alpha hydrogen. Those are the two differences. Ammonium silver nitrate, tolerance both. Brady's both. Saline both. Aqueous potassium hydroxide. Only alpha hydrogen. This is converting to aldol. Aldol. 193. Answer 4. Physics getting better, math getting better, and bio getting better. You're supposed to feel so. Just do something if you're not feeling good. Make your this effort your last effort. Can't imagine how happy these students in faculties. Be like them. Shape up your own future. I lost the annotation. Anyway, I'm going with. Which of the following distinguish between this CH2, obtain this? Answer number 3, Clemmensen reduction. 194, answer 3. 195. Ethyl benzene can be obtained from this COCH3. Yeah, that's again possible. See the same sort of a question that they are again asking about the Clemmensen reduction. Clemmensen reduction is possible for that. So the first statement is correct. This is the Clemmensen reduction. Ethyl benzene is this. Carbonyl compound of this, this has CO, is reduced to CH2 group by, not this, by this. 195, answer 3. Acetophenone. This is acetophenone. Acetophenone. I'm planning this little party for kids, you guys, only for you guys, because we were a little harder after spending like 100 million rupees. Really hard up. So we're going to throw this big party later, but for kids, only you guys. We're going to plan a little party, but I'm not expecting you guys to do anything. Only come to the party. I'm doing all this. I've given all this organizing and everything. They're like so inspired. 25 students. They made a different group and they're going to plan what they're going to do there. And I asked them to plan a couple of these games that you guys can play. Just get there and have fun, forgetting everything on that day. Sinhala English 24, only for 24 and 25. Not this other thing in our count again. Okay. Question number 196. Which of the following is used to prepare Brady's 196 answer? 1. 2 for DNP, 2 for dinitrophenile hydrogen. 197. This is a weird question. I don't know how they have taken this answer. Even this one, this can see this is possible with PCC. And number 3 can go to number 4 with DIL-H2SO4. Anyway, because this is came through 1996, let's only get the knowledge of conversion. So CO, addition of HCN. So OH and CN, reduce with lithium aluminum hydride. CN become CH2NH2. H2SO4 170. OH gets away to give the double bond. Then sodium nitride DLHCl, NH2 to OH, PCU3, OH to Cl, KCN, Cl to Cn. So like unbelievably longer for question, standard question. But you can go like this. One time in your papers, you would get this kind of situation. In modern chemistry, they were taking this kind of a compound with halogen connected. Other than that, this is little weird, okay? Anyway, if you have this kind of compound, then chlorine to CN, then keep OH2 double bond, then CN to COOH. Okay. Anyway, you can get answers 2, 3, 4, whatsoever. 197. Get the knowledge, then forget rest of the parts. Enoch, you everybody know Enoch, I guess. So smart. Seriously, for chemistry, he reminds me my very first student, Punsala. I was talking to Punsala even yesterday. She was still. I would show you guys these recordings. I can't bring her here because she is really busy. But still, she's right after I said, she says it's okay, ma'am. I have classes, I have lectures, but still I will come. They are having quizzes these days. She said she will come on that Friday 17th. She said that she was talking to one of these students who's doing this first degree in Japura because she's in Japura. How hard it is just to enter to this chemistry special degree. Then she was talking about me. My chemistry teacher has done everything, and she could be able to convince everything really nicely. That's why she was in that medical faculty and whatsoever she told me yesterday. So he has same sort of a talent. For me, it's extraordinary. I'm not sure about other 2 subjects, but his chemistry is, whatever the thing I'm asking, he has the memory. Whatever I'm asking, he's just saying this is this, this is that. Okay, just be like that. Because he is really inspired. He is really inspired about getting some sort of a, I think, you know. No. Were you, no, you went to, how do you know him? Well, you guys were here when Gino was here? No, it's only you. You two, you didn't see us. Gimanthan. I don't know. We don't know. That he's from Prince. Yeah, Prince College, you know. And I very first day I told him that I'm going to make Prince proud. He would do that. Okay. Question number 198. He doesn't have a super brain, but he's so much into this. And having a very good communication with me whenever he feels something and when he feels bored. Ma'am, I don't feel like studying today. He's just texting me. Be like that. Then I'm giving him some sort of a solution. Then he's being really happy and go through that. And ma'am, now I'm really okay. I'm studying again. Like that. Okay. Which of the following reacts with 2,4-DNP? This is hydroiodic. This is hydrobromic. No reactions with acid, phenol, no reaction. Ethanolic sodium ethoxide. Ethoxide mean this. Ethanolic mean again C2H5. Sodium mean this sodium. Ether with phenol, we never done any reaction. The next one is sodium bicarbonate. This is a reaction with sodium bicarbonate. B. CAD, aliphatic participate SN, aromatic no SN. Okay. And this is possible with alkyl halide. With alkyl halide, formation of ether is possible. But phenol, no reaction. Understood? 198, only the correct answer, 5. Whatever the supportive information, just pop them down. Okay, 199. This is Greenard. This C6H5 react with this hydrogen to convert C6H6, and so that this HCOO is connecting with MgBr. This is a reaction. So this is acting as proton donor. So the first statement is correct. Then second statement saying something else. We go back, they say, greener add across CO. See, negative charge attacking here, nucleophilic addition, double bond is dissociating towards oxygen. You are going through this. That's again true, but no connection. This is acting as acid. This is nucleophilic addition reaction. No connection. 199 answer 2. Or you can add any acid here, or any acid. Nadija, what is it, darling? It's okay, you can discuss with Amaya, with Sabtala, ask your question. Anything you want to make sure, clarify? 200. Okay, organic compound Y. This again has issues from 1997. Let's get the knowledge. Y dissolves in aqueous sodium hydroxide. See, I have given all these phenol, aldehydes, ketone with alpha hydrogen, carboxylic acid, acid halides, amides, esters, all dissolved in aqueous sodium hydroxide. Brady precipitate, aldehydes and ketones with Brady. Failings, it's supposed to have aliphatic aldehyde. No aliphatic aldehyde on this one. No aliphatic aldehyde here. Dissolved in aqueous sodium hydroxide. This one. And also this one. Directly you don't see it is dissolving in sodium hydroxide, but this is directly dissolving because phenol dissolved in sodium hydroxide. But if you go with 4 and 5, but still you have this alpha hydrogen. Okay, so these both can go through aldol condensation. But still, when you make the aldol, its size become twice of this. So this is become so much longer, and this is also become really longer. Maybe that's the reason they were not taking these two answers that dissolve in aqueous. So when the organic part is larger, it's not dissolving in sodium hydroxide. In that way, they were taken answers 2. Who got the answer 2? Well done, well done. Question number 201. Which of the following mechanism of this true? HCN dissociate into QCN minus. That is as a nucleophile, nucleophilic, dissociating double bond CO towards oxygen addition. So it's nucleophilic addition. And then first attack coming from this. Then the second attack, it is like we are always drawing our arrowhead towards hydrogen. But here this is saying second attack is by H plus. In a way, they were taken it as correct. Anyhow, the second step is joining with hydrogen. That is the reason they have taken the second one correct. Cn minus on oxygen wrong. This CO oxygen is again wrong. 201. A, B correct. Answer 1. Question number 202. For the purpose of distinguishing qualitatively, quality, not quantity, how much, quality means whether it's present or not, between these two, aliphatic aldehyde, aromatic aldehyde, maybe we can go with pairings, and also this doesn't have alpha hydrogen as well. HCN, both gives cyanohydrine. So this is number 1. Then 2, aqueous KOH. This has alpha hydrogen. So aldol condensation. This is no alpha hydrogen. So going through aldol. Okay. Then this one, this 2 hydrogen gets away with this oxygen to convert them into these double bonded compounds with between CN. Those are imines. And this is 2,4-DNP Brady, orange color dye from both these two. So in that case, answer supposed to be Number 2 here, they were not taken none of the above, but they were given answers all here. If you have taken the answers too, that's sort of possible, but the thing is you don't obviously see anything. You have to go through another some sort of a method to identify whether this reaction is occurring or not, because there is no color change or whatsoever. Hello, sir. What? Well, that's full. They are not writing that much. I mean, not full වැඩේ ඉන්නවා නේද? දැන් කියන්නේ දැන් ඉතින් දිගට දැන් දැන් මොකද අර පොඩි කාලේ. I'm happy for them now. Question number 203 is 202. So whatever this answer, okay? Moving on to question number 203. Organic compound, they named as C, dissolved in aqueous sodium hydroxide. That all has this, so we cannot get any support. No COOH, not dissolved in aqueous sodium bicarbonate. So we can omit this groups. C gives precipitated Brady. No Brady here, no carbonyl, no Brady. 1 mole of product obtained by the reaction. Water is eliminated very easily. Okay. This is the product of with HCN, OH and CN. If you go with 1 and 2, only remaining these two. But when you want to remove water, this is going to this tertiary carbocation. This is tertiary, and this is through secondary carbocation. So through tertiary, it's more easier. So, but they were given answers all again. We can get answers too, but it is again, it will like not that clear because we were not talking about carbocation making of this. We never done this reaction like with this CN, this carbon, they were taken as tertiary and secondary. How possible? What are the interactions when you are joining with CN? We never done that, so they were taken as all. 2 or all. Sir. Sir is taking pictures because this is the yeah, I forgot to tell you guys. Last day here. It's making camera. Just look at the camera.
May class.
I'll we're gonna miss you. Even yesterday, he was taking a couple of these pictures for. Behind it. Okay, so this is your last day here. Today is 9th Thursday. 16th Thursday, no class. 16th Thursday, don't come here. Nobody would be here. For 16th Thursday, I'm going to send you guys this recording. So you're going to go with the recording. 23rd, I'll ask you to the group. If you want a recording, I would send. Otherwise, you can just, I know you guys are not celebrating Vesak. I don't want you guys to do that. It's not, I'm not religious, I'm really religious. But shaping up your future, just give the priority to that. Then we're going to meet on 30th Thursday. That's at the Grand. Do you know where is it? Do you know where this Domino's pizza? Just if you go to the Domino's Pizza, it's a good thing that they were very recently opened this Domino's Pizza. Okay, this is the Domino's Pizza staircase. Go to the staircase, then look opposite. You would see this newly tarred, this still this final court supposed to go. What are the red carpet tar carpet. So the final this what do you call that? Final what is that of the road? Something is saying. That is still to done, yet to done. So it's going to be this black color new road. Carpet, yeah, the carpet part is, yeah, carpet part is not done. So then you are just through this walkway, you are just entering to the grand, and the Mahesh, Manjula, Suji, sir, somebody would be there to welcome. Okay, I forgot to tell you guys that. Yeah, I think Arham, I think he would watch this. Somebody tell him, okay? Okay. So this is the last day that Rala Metana took in. You guys are okay, but 25 class, like, you know, there were like 3 rows like this. I don't have space to go into tech students. That life was really terrible. They will keep asking, ma'am, when are we leaving? When are we leaving? When are we leaving? Finally. Anyway. Okay, so question number 203. This is the answer. Moving on to question number 204. Electron pair on the nitrogen. No. Electron pair of the carbon is donating. See, carbon donating electron onto this carbonyl carbon. First statement wrong. Second statement correct. This is the electron transition because we are providing CN lone pair onto this carbon. So CO bond is dissociating onto oxygen. 204. Answer. Question number 205. Will be reduced by lithium aluminum hydride. That's what happening when you are going through this short node. Otherwise, see how much time you have to go through the node to find who's reacting and who's not reacting. Now everything is one single place. Go through this magical short node as these past students are saying. Okay, so this is converting to CO. CO converting to CH2. But alkene no reaction. This is toluene. This is alkane no reaction. CD, alkene and alkane. 205 answer 1. If you feel like you have forgotten something, just write refer short note. If you want, you can write this. Otherwise, just write refer short note. Ethanol, and this is ethanol. Ethanol. Most appropriate. This 2 hydrogen gets away with this oxygen, making this double bond. The compound is imine. That's possible. This is the ammonical failing, copper, that is failings. Brick red with aliphatic aldehydes, that's also for that possible. Tolerance. Silver with aldehydes, this is aldehyde, that's possible. So 206, answer 5. Manjula? Manjula? Manjula, remote එක මෙතන කොහෙද? ඔව්. මේ හුලං එනවා වැඩි වගේ. කොහෙද? කොහෙන් යන? ඔව්. 16 දාලා මැක්සිමම් දාලා. බලන්න ඕනේ. ඔව්. දෙන්න මන්ජුලට බලන්න. වැරදිලා ප්‍රෙස් කරන්න. Okay. See the noise and everything. I was just feeling uneasy. I don't like noises, and we're gonna have this calming environment there. Luckily, you guys have at least couple of months. I was saying all this to 2023 students are there. Even 2022, I guess. Yeah, now it's been almost 2 years, I guess, is it? Renovations. Okay, question number 207. Insoluble in aqueous sodium carbonate. No COOH. No COOH. COOH. Okay. Dissolve in aqueous potassium hydroxide. There are a lot of compounds, but here you have, for that, you have this phenol part. Ester, I'm just leaving, and that phenol part is there as well. Number 4. That taken as, again, dissolving in sodium carbonate, insoluble. This is dissolving. This is not insoluble because this is dissociating to give sodium hydroxide, then, and that can react with ester part. So we have to omit answer 4 as well. Answer can be 1 or 3. Gradient tolerance both, but this doesn't react with tolerance because this is directly ketone part. Question number 207, answer 3. 207, answer 3. Okay, done. 208. Heating aldehyde with toluene reagents produces, toluene aldehydes, this silver mirror, true. Acetaldehyde undergoes self-condensation in basic medium, and that is this aldol. No connection. 208, answer 2. Question number 209. This compound gives a silver mirror. No. To have silver mirror, there is no aldehyde part. Orange precipitate with braid is true, but since this is wrong, A is wrong. Ammonical silver nitrate, yeah, no silver mirror. This has terminal alkyne, this part. So B is possible. This is off, I guess. Manjula, decolonizes bromine water with this. Make a battery full tibbada. Me off either. So bromine, the part is that is correct. Oh, all right. The full charge in 209, BC correct, answer 2. Question number 210. Ammonical silver nitrate can be used to distinguish aldehydes and ketones because aldehydes are easier to oxidize than ketones. That is the reason. Okay. Question number, because you cannot oxidize ketone. 210, answer 2. Moving on. Okay. Question number 211. ඔය දෙකයි දාන්න. ඔය දෙක දාන්න charge එකට. the product that results when 2-butanone. Okay, commonly 2-butanone, I'm just going to take as any aldehydes or ketone. Addition of D2O, C, hydride hydrogen onto carbonyl hydrogen, carbonyl carbon. Water hydrogen onto carbonyl oxygen. Hydride hydrogen, carbonyl carbon. Water hydrogen, carbonyl oxygen. So here 211 answer 3. And this is the example they were given. Question number 212. Answer 4. Pyrocarbon. Answer 4. Pause the annotation again. Question number 213. Again, you have a reaction scheme here, like a little conversions, couple of conversions together. Let's first find these connections. Here, this oxygen has replaced with this whole part. And you guys know this whole part is the 2,4-DNP, and that is this. Okay, so this is then orange precipitate. And CHO becomes CH2OH, reduction, either lithium aluminum hydride or sodium borohydride. Then OH2Br, PBr3, PBr5 or HBr is also possible. A reacts with 2,4-DNP to give C, correct. Both lithium aluminum hydride, sodium borohydride can be used to convert A to B. That's also possible. Not KBr. HBr is possible. C and D are water soluble. This is a white color precipitate, that is C. D definitely is alkyl halide, water insoluble. 213, A, B, correct. Answer 1. Uh, 214. Sodium metal, here I have underlined. Terminal alkyne hydrogen, terminal alkyne, alcohol hydrogen, phenol hydrogen. This is reacting with sodium hydroxide but not with sodium. And this part again I given to short note, just refer the short note. 214, answer 4. Who got this answer? Is it? Nobody. Ah, am I? Professor, why? Didn't? I didn't hear you. Because you just skipped that. Why? I just don't know why you didn't do this question. Saptala, why you didn't do this question? You couldn't get the answer. Did you understand the question? Nadija? You didn't try. Because why didn't you try? Because you're feeling uneasy. And you couldn't get the answer, so you just skip. Okay. See. Get this. Okay, I'm going with electrophilic substitution. Electrophilic substitution. Okay. Electrophilic substitution. To happen this. What's supposed to go with this initial compound? Whatever the compound, let's say we have A. That electrophile is coming onto attack A. What are the qualifications that A is supposed to have? For electrophilic reactions? Electron density of A is supposed to be high. High. Is that clear? Then only this has higher and higher ability. It's like a beggar is going to a rich person, generous person, let's say. This is so generous giving electrons away. Then E plus is very readily try to get closer. Okay, let's say now a nucleophile is coming. To get the nucleophile, what is the qualification of A? Electron density of A is supposed to be really lower, really lower. If the electron density is lower, that's how it is happening. Usually rich people doesn't empathize on normal people. Rich people always empathize on poor people. So this is rich person empathizing on poor. When the electron density is very, very low, nucleophile can attach readily, very easily on A. So the electron density of this carbon is supposed to be very, very low. So that negative charge can attack easily. Understood? Okay, they were given, I have written everything. If you analyze all these 5 answers, you're supposed to analyze, it takes a lot of time. That's why, since this is taking a lot of time, you're going to save time from other questions. Even with these harder, larger questions, students are saying they had more than enough time because other questions are really, really easier. This is really confusing question, that's true. That's because you have to go through everything because they are given different examples. But before that, okay, so this is the nucleophile. This is attacking onto this carbon. CO bond is dissociating towards oxygen. And this NGX is joining back onto this oxygen. That's unstable. So it is taking up one hydrogen. MGX gotten away, hydrogen is joining here. This CH3 is joining here. CO is polarizing towards this way. When the electron density of this carbon is lower, CH3 is very readily, very easily donate its lone pair. You have a negative charge here. Donate its lone pair onto carbon. Clear that. So that what does the inductive effect do? Let's say you have an R group here. It is providing electrons onto this carbon. Nucleophilic addition rates increasing or decreasing? When decreasing, inductive effect greater means you are providing more and more electrons. So it is discouraging rich person to give money. It is discouraging electron-rich nucleophile to donate its electron onto carbon. Understood? So we're going to find out who's providing electrons, who's dragging electrons away. Okay, so there are a couple of these they were given when both R and R equals pH, that is phenol, benzene. So this is the condition. One side hydrogen, then the next one. One side CH3 and the second side benzene, and that is this condition. And both sides we have CH3 groups. Or one side CH3, one side hydrogen. Both sides hydrogen. That you know, even benzene or CH3 groups, they are weak ring activators. They supply electrons onto wherever to the neighboring atom. So this is a neighboring atom. So from these both sides, whenever you have CH3 here or benzene here, they are providing electrons. Clear that? So when you are having hydrogen here, no such effects. When you are having hydrogen, this carbon's electron density is very, very less. So that CH3 can join onto that carbon easily. So that highest nucleophilic addition reaction rate goes to when you have hydrogen here. When you have hydrogen here. Understood? Everybody? Okay. Next one is CH3. But then this is making the least because the plus charges also can delocalize it in the ring to become more stable. Understood? So let me read this. Okay, this is nucleophilic addition. Since nucleophilic addition, when plus nature of carbonyl carbon is high, easiness of joining of nucleophile increases. Benzene, weak ring activator. CH3, inductive effect. Both increase electron density on C+. Rate decreases. Since C+ delocalized within benzene ring, nucleophilic addition rate is further decreasing when you are having benzene ring. Understood? Okay. Okay, I'll keep this up with this. Okay. Rest of whatever part you want to write. Okay, go to the first page of your Tute, right there, 215. Okay, all these harder, no. Here, top one, the color one, color top. Write their harder questions. Yeah, there. Somewhere write Q215. Write all the harder questions somewhere continuously. Then when you are coming back, then check that questions so that you know then these questions are harder. You're going to go again with those questions. Harder questions right on the top page. Like I'm writing everything. Whenever I feel like something I want to check again, so I'm writing somewhere here. So it's up to you. Wherever, just continuously with commas, just write that. Next day when you are checking, then you know, I have harder questions on this tune. I want to go through again. Because everybody did this unsuccess. Everybody was. Okay, 216. Ammonical silver nitrate, aldehyde, yeah. No. But this is again terminal alkyne goes with white precipitate. This is going with silver mirror. 2 for DNP, Brady, CHO, yeah, COCH3, yeah, COS, COCH3, yes. So 2 does by all, okay, by all. But 1 does by only A and D. A and D, 216, answer 4. When you are going through this kind of questions, just go through this kind of a little like numbering, then you can get the answer very easily. Who has everything? Saving time, methods to save time. Find your own methods to save time. Communicate with yourself. Analyze yourself. Reaching 100 marks is it's exactly on you, something on you. Analyzing your own self, understand your mistakes and improve them. 217. Which of the following statements true about this compound? This is astrophenone. Reduced with sodium borohydride. You are coming to this. Optically active. Yeah, you have this carbon, pyrocarbon. This is mild ring deactivator and also orthopara. Bromine gets here. That's true. This is the Clemmensen reduction. The Clemmensen reduction is supposed to give this. From this, you are supposed to come here. This is, and that is not optically active, that's optically inactive. So that's wrong. Oxidation is give this. If you want to stop here, go with PCC. 217, A, B correct. Answer 1. To 18, just refer question number 211. Hydride hydrogen carbonyl carbon. Water hydrogen carbonyl oxygen. 218, answer 1. Um, 219, answer 2. Yes. Amaya? 219, answer 2. Nadija? Did you try or you didn't try? What is the answer, Dhoni? 5th one. Nadisha explained this, but before that, let me explain this. Dhoni again. This is the mechanism. Cn minus attacking onto this CO. So the reaction is nucleophilic addition. Plus nature of carbon is high. When the plus nature of carbon is high, nucleophilic addition reaction rate is supposed to be greater. Then let's find out what are these Y. These Y are I have mentioned here. OH, strong ring activator. CH3, weak ring activator. So they are activating ring means they are providing more electrons. So C plus is weakening. Chlorine, weak ring deactivator. NO2, strong ring deactivator. Okay, Nadija. Starting from this, now explain. It's okay, darling. Go slowly. It's okay. Saptala, explain. OH group is providing electrons. So it decreases C plus nature. The greatly decreases because this is the strongest ring activator. Okay, now next one is this. Why? CH3 is also providing electrons, but now it's not providing as strong as OH. So it is decreasing less. Okay, now tell me about this, Saptala. It's deactivating. So it's increasing the C plus nature. So it increases the reaction rate. Now explain this. It is more and more deactivating, Nadija. So it is making the C plus more and more positive. So the Cn minus to attacking become more and more easier when C plus become more and more positive. Last question that you have explained everything. What is the number? Yeah, 215. Okay. Write there Q215. So here the answer is 2. Just write here, refer 250. And 202 is there too. See? Same sort of a question. Two and 215, you can refer them. Question number 219, answer 2. Moving on. Question number 220. I want you guys, if you guys still feel even a little discomfort, listen the recording again within that same week. Again, product is asking, this is normal carbonyl. So 1R group for carbonyl, and this is ester part. So either acid halide or ester, 2 carbonyls, 2 R groups, 2R groups. This is the R group, see 1R, and here 2R. 220, answer 5. 220, answer 5. Okay, question number 221. boiling point of butane is lower. Butane is lower because this has London forces. This has dipole. Okay, and then that is wrong. Only sigma bonds present in, yeah, only sigma. This is saturated. This has both sigma and pi. That's true. So question number 221, answer 4. Question number 222. This compound, zinc mercury conc HCl, see this has HCl. This has HCl. Then it can dissociate this compound from here. Then let's move on to the reduction part. Then this part, it's just existing as it is. This doesn't have, sorry, this part is just existing as it is, like this. But this CHO is reducing to CH3. Then again, from this side, you get C6H5COOH. Clemmensen reduction cannot do anything with that normal ester. So it's just existing that side. 222, answer to here I have written, ester hydrolysis can go through acidic and basic medium. 222, answer 2. All right, 223, by little we are getting this, finishing everything. This is aldol. If you want this knowledge, so what happened here is, this alpha hydrogen is getting away with this OH, giving its electron to this carbon. So you're going to get this nucleophilic carbon, and this nucleophilic carbon is this one. Then this is attacking onto this. See, then I'm just showing this part is this part. Then when you are heating, water molecule can get away. Then it is getting hydrogen from this, not heating part they were given. They were just given this initial compound, and no double bonds in any of these. So this is a longer chain. So this is a longer chain. This CH3 has shown separately. Okay, question number 223, answer 1. Anybody feeling uneasy with aldol? We can do a couple of more like on board if you feel that you guys need this knowledge. Question number 224. Answer 2. Finish. Oh, this is again that Navala house. Moving on to my last book. Question number 225. Anu, go get a little wash if you want. Are you okay now? I'll let you to have a little nap. Okay. Self-condensation with sodium hydroxide. For that, you're supposed to have alpha hydrogen. Yeah, you have that. And through aldol, you're going to get this product. Okay. So this is the nucleophilic, the second one I'm just showing. Okay. Then oxidation with ammonical silanitrate. This is giving the white precipitate with this terminal hydrogen part, that's true, but that is not an oxidation. So we cannot write A here. We can write A here, we cannot write A here. Moving to the second one. Again, self-condensation. There is no alpha hydrogen, but silanitrate, that is true. So C. CHO becomes COOH, that is oxidation. So I'm going to write B here. Then C, I have alpha hydrogen here. So it is going through the aldol. So I can write C here, but nothing to go with tolerance. No aldehydes, no terminal alkyne. So I cannot write C here. Then D, you have alpha hydrogen here, aldol, and then you have CHO converted into COO minus, so that is oxidation. So I can write D here. Commonly, only we have D. 225, only D correct. Answer 5. Moving on to carboxylic acids. Again, we are moving to this easy acidic strength. Now we have the knowledge. Here, A, inductive effect, increasing or decreasing acidity. No, inductive effect, acidity, increasing or decreasing? Decreasing, yeah, decreasing. So that's the lowest. All this has these negative, electronegative chlorine. So who has, yeah, this is less electronegative, then that is the second lowest. And then B, 1 chlorine, but C, 2 chlorine. C is the greatest. A, inductive effect, least acidity. If you have still forgotten, just write that. Inductive effect decreases acidity. Inductive effect decreases acidity. 226 answer 4. I want to write that too for students. Answer 4. 227. 3-nitramine, 1, 2, 3. The para position, more acidic than benzoic. Yeah, this is dragging electrons away. The nitro group exhibits a meta-directing property. Yeah, it is having the meta-directing property, but the reason supposed to be it is ring deactivity. Not explaining that. 227 answer 2. 227 answer 2. 228. The reaction between carboxylic acid and alcohol is catalyzed by H2SO4. Yeah, esterification. But see, OH group of carboxylic acid gets away with hydrogen of OR. But this says carboxylic acid hydrogen, this is supposed to be OH, and OH group of ethanol, that's again wrong. This is supposed to be H. Okay, question number 228, answer 3. Moving on to 229. Manjula? Okay, get the piece thing, let's finish. Get down it. Get down it. Yeah, the person again. Okay, thanks everybody. Moving on to question number 229. This is Grignard ethanoic acid reacting through, because this C2H5 gets this hydrogen to make C2H6, and same sort of a question that we did earlier, I guess 220. Yeah, question number 199. Adds across the group of ethanoic. This is for ethanoic, this is wrong. This is okay for carbonyl compounds. Here, acid acts as a H plus donor. This is okay for carbonyl. That's wrong. But okay, question number 229, answer 3, and write there question number 199 as well. Q 199. We have the same sort of explanation. 230, again acidic strength. I'm going to go with the answer. Least one is just the normal phenol. Then when phenol is attached to NO2, NO2 is dragging more and more electrons away. Hydrogen can get away easily as H+. So then the acid is greater. But these two are carboxylic acid way greater. And out of these two, fluorine is less electronegative comparing to fluorine. So having 3 fluorine has the highest acidity. And also we consider both these compounds actually as strong acids. 230, answer 4. Okay, moving on. 231. CF3COH acting as a strong base. Memorize that. The electron pair forming on the bond in carbon, fluorine, this bond, is attracted towards the fluorine atom, so that it is dragging more and more electron away from hydrogen. Hydrogen can get away as H plus easily, so that this is acting as strong acid since you have 3 fluorine here. This one is also acting as strong acid. 231, answer 1. 232. On heating, the product obtained from the reaction of an organic compound X with excess ammonia. Y was obtained. It simply means if you react this with X with ammonia and heating, then you are getting some sort of a compound. We don't know why. The compound Y, when heated with P2O5, that thingy comes with amide. That we know. Amides with P2O5 is going through this dehydration. CONH2 with P2O5 become CN. This oxygen and this two hydrogen gets away. So to react with P2O5 is supposed to be amide. With to make amide with ammonia, they are supposed to be carboxylic acid. Alkyl cyanide forms from amide plus P2O5. So Y is supposed to be amide. Then amide comes to carboxylic acid. X supposed to be this. 232, answer 1. Okay. Another condition that we came across P2O5 is what? Yeah, one more condition is there. Somebody. For inorganic chemistry. P2O5. Those are throughout the whole syllabus, only 2 conditions for P2O5. Inorganic chemistry. Group 14. We made a compound. Something dehydrated with P2O5 to make that compound. Inorganic. Group 14. Under carbon. Malonic acid, P2O5, carbon suboxide. Right somewhere. Since you have forgotten that. Malonic acid, P2O5, carbon suboxide, C3O2. Go and check that. Question number 233. Author is wrong. Author is wrong. Para is wrong. See, both groups are on same carbon, wrong. Partial plus charge, wrong. Okay, 233. Answer 2. Just underline like this, then you can show these are wrong. This is author wrong and para wrong, and you can show this, underline this. Or you can highlight, and you can also highlight here. Anup darling. Tute, පොඩ්ඩක් ගිහිල්ලා මොනවස් කරන් එන්න බා වගේ. යන්න. චුට්ටක් ඇවිදලා එන්න. It's okay. අර පැත්තට ගිහලා චුටි වෙලාවක් එන්නද? Everybody has to Okay, so we're done with 233. Moving on to question number 234. Nucleophilic substitution, because initially this is nucleophilic addition, breaking the bond. Then this is releasing or leaving this chlorine away, but finally Cl gets away and NH2 joins, so that's nucleophilic substitution. 233, answer 3. Question number 234. 34. Yeah, sorry, 234 answer 3, okay? 235, again, acidic strength, increasing order. Nadija darling, just this is the answer. Now I want you to explain this answer. Why this is the lowest? Oh, why this is having some sort of acidity? It comes to the short note. You can go through the short note and explain this. Yeah, you don't want to do the question. I'm giving you the answer. I want you to explain the answer. Okay, now tell me why this is greater than phenol. Because NO2 is ring deactivated. So it is supporting to H plus leave easily. Then tell me why this is greater than this one. Second one is phenol, but third one is carboxylic acid. Carboxylic acid. So this has 2 hydrogen. Always 2 hydrogen is more electronegative. Inductive effect doesn't compare for these two, Tony. If you go with the inductive effect, you're supposed to say this is less acidic. Inductive effect decrease acidity, but here you have 1 oxygen, here we have 2 oxygen. So that more electronegative, so acidity is high. Saptala, explain these two. Why formic acid has the highest acidity? Yeah, now you're going to talk about the inductive effect. Now CH3 is providing electrons less acidic, no inductive effect. No R group here, no R group, no inductive effect. So the acidity is high. So Nadija, only solution is the short note. If you know the short note, if you have this memory, it's not necessary to do any question, then you can answer any question. Understood? Go through the short note and memorize, it's the must. Okay. Question number 235, answer 4. Question number 236. Okay, this is the salicylic acid, right? That salicylic acid. Sodium carbonate, OH doesn't react. OH just existing as it is. But this COOH becomes COONA. And sodium carbonate with carboxylic acids, they release CO2. See, they release CO2. So CO2 is evolved, that can be accepted again. 236, answer 5. So this is the explanation for D. Question number 237. This explanation I want from, this is actually about the boiling point that comes with intermolecular interactions. Amaya darling, can you explain this answer? C is the lowest, and that is this. Why this is the lowest? Because its intermolecular interaction is dipole-dipole. Out of all these, dipole is the least because all the other three has this direct OH, so that all the other three has hydrogen bonds. But still hydrogen bond strength is greater when molar mass is high. So that when the molar mass is increasing, boiling point is increasing. So that this is having the highest boiling point, highest molar mass. 237, answer 1. $238. Butene dioxide in dioxide. This is the only possibility. Yeah, it is showing to this carbon, it is showing cis trans isomerism. Then CO2 with sodium bicarbonate, that's true because it has two COOH groups, so making two COONA. Then decolorizes bromine water, addition through double bond. Lithium aluminum hydride, yes, it is reacting. These COOH groups become CH2OH. But here you have one single letter C. Remember, I'm just saying, whenever you are doing this chemistry, one single letter, one dot, one comma is really important. This is supposed to be E, not A. That's why it's wrong. A, B, C, correct. 238, answer 5. Who got this correct answer? Palita, Manjula and Nondara Visayade. Saptara, anything? Can I move on? 239. Okay, so lithium aluminum hydride, acidifying. CONH2 become CH2NH2, that's reduction. Lithium aluminum hydride reduce carboxylic acids, so that's also possible. Then to that, you are adding this benzaldehyde. NH2 hydrogen gets this oxygen, making this part imine. P and Q. 239, answer 2. Question number 240. Heated with sodium hydroxide. This is amide dissociating from here, and this is ester dissociating from here, and then reacting with sodium hydroxide. NH2 aniline is basic, no reaction with sodium hydroxide, so existing as it is. But here the remaining part is phenol. Phenol react with sodium hydroxide, become ONA. And then the next part is this carboxylic acid part, HCOOH, that is reacting with sodium hydroxide to produce COONA. And then the next part is part that is coming from this amide, that is again carboxylic acid, COOH, thus again converting to COONA. 240, answer 3. Moving on. 241, acidity, residue. I want this expression from you. Okay. It is not acting a strong ring activator. This is just phenol. Just think about phenol. You're going to talk about ring activator or deactivator if another one is joining. This doesn't have any other. This has only phenol. Okay, why Vasaktala, why this is acidic? Because this is releasing H plus and then this negative charge can delocalize within ring. So it is acidic. Why it is less acidic? Because you have only OH here, but all these are carboxylic acids. So the carboxylic acids are always more acidic because this has two negative electronegative oxygen. That's why it's more acidic. And then why C then? C is carboxylic acid, so acid is greater. But comparing to these two are having more electronegative NO2 joint. Sorry, strong ring deactivator. So these two are getting electrons away. So more acidic. Why this is the most acidic one? D is the most acidic. What is the reason for that? It is dragging electrons away from ortho or para positions. So that has the highest acidity. Yeah, I'm showing that. 241, answer 2. Question number 242. ST and U asking. Lithium aluminum hydride reduces CO to alcohol CH2 or COOH2, CH2OH. To that, PCC, mild oxidizing agent. CO is converted into COH is converted into CO. This is primary alcohol is converted into aldehyde. Clemmensen reduction, both these CO is converted into alkane CH2. 242, answer 1. Okay. Question number 243, acid derivatives. So to this initial compound, when you are adding this one, so this is going through this esterification. So that OH with this acid halide is converted to OCOCH3. And then addition of excess Grignard, once you add Grignard, this can join with one carbon. And this one breaks from here. This side just become again OH. But this side, you have this CH3COO, that is CH3, this part. Since this is ester, this can join with another two groups. Okay. So 243, answer 2. Saptala, what is your answer? Because you didn't do the rest of questions or you didn't do this question. Why were you feeling uneasy? See, I'm showing. So to this part, you are adding Grignard to get there. And you're going to get this one, Cl minus, CH3COCl. So to that Grignard, you are joining two separate groups. Tony, why you were feeling uneasy? Not remember? Okay. Question number 243, answer 2. Moving on. 244. Major products A from reaction between above, that alcohols does not react with sodium hydroxide, do not react, but carboxylic acid making this sodium source. 244, answer 3. 244, answer 3. This again, carbonyl, 1R group. This again, ester, 2R groups. 245, answer 5. 246. So lithium aluminum hydride to this compound, this CO is reducing to CHOH, and amide CONH2 is reducing to CH2NH2. To this, you are adding this ketone. Of that ketone, this oxygen is getting away with these two hydrogen to make this imine compound. 246, Answer 2. Well, oh, Mahesh. Really? Find another driver. Question number 247. True regarding Manjula. Manjula, සුජිට පොඩ්ඩක් කියා දීලා දෙන්නද? හරි. This is a compound. Decolonizes bromine water. Yeah, through this double one. Liberates ammonia when warmed with aqueous sodium hydroxide solution. Yeah. This is a reaction to release ammonia. B, I'm just showing again. Gives an orange colored precipitate with 2,4-DNP, that is ready, so that they are supposed to be carbonyl carbon, not amide, this carbonyl, okay? Give a primary amine when treated with sodium borohydride. Remember, amides reduce only by lithium aluminum hydride. If you don't have the memory, write this down. 247, A, B, correct, answer 1. Uh, 248. Precipitate with silver nitrate, supposed to have ionic halogen. Yeah, this is definitely ionic. Silver iodide yellow precipitate. This is covalent and no reaction with water as well. But here, when you add water to acid halides, they are converted to carboxylic acid and this HBr. So silver bromide pale yellow. This is again has this chlorine. Gives HCl, makes this AgCl white precipitate. 248, A, C, D correct, answer 5. Um, 249. Okay, this ester, this ester. So we don't have any methods to separate between two esters. So I'm going to break this. If you break this, you're going to get this benzoic acid, phenol. Other side, this part become this aliphatic carboxylic acid. And this compound is this. This is a secondary alcohol. Let's see. First, the hydrolysis is true. Diazonium salt, yeah. Only phenol making diazonium orange precipitate, true. Acid hydrolysis, add bromine water, that's again only phenol gives this white precipitate, that's again true. Bromine sodium hydroxide, no reaction. Ammonical silver nitrate tolerance, no, see, no aldehyde or no ketone. Sorry, no aldehyde, no aldehydes. Terminal alkyne or formic acid. 249, A, B, correct, answer 1. 250th question. See how many questions you are doing. Okay, aqueous nitrate. This is little problematic. Tertiary. These two are okay. These two are really okay because these in aqueous medium they are reacting. But anyhow, we have to choose an answer. So I'm going to go with who's not participating as in this. And this is benzyl carbocation stable. And this is tertiary carbocation stable. So this can give us a little, let's say, Cl minus to the medium. But vinyl carbocation no SN because it's S character high. And resonance stability gives the double bond nature between this CCl. So no SN. 250, answer 5. 251, I'm just skipping. If you want, you can write answer 4 and cut down this one as well. Then the best possibility is number 4. Anyway, that's a little older, not a good explanation. Benzamide. This is the benzamide. See, they were only given the name. You should know this compound. Okay. Sodium nitride, NH2OH. Barium hydroxide with any strong base releasing ammonia. No reaction with these two. 252, AB correct, answer 1. 252, AB correct, answer 1. I'm going to skip 253, just cut that down. Cut that. You don't want that do again. This is the benzoyl chloride. This is an acid halide. Amide acid halide, no reaction. But amine with acid halide, they are producing substituted amides. Phenol acid halide, they are producing esters. Never done such reaction, let's say like chloroform D, no reaction. 254, BC correct answer 2. $255. Lithium aluminum hydride and ethanol. Convert CONH2 to CH2NH2. Sodium nitride DHCl converts NH2 to OH. PCA3, CH2Cl. Then add Grignard reagent to make it Grignard reagent. Then add carbon dioxide H2O. O to this compound, alkaline KCN to CN. Then acidify to convert it to COOH. Others, you cannot get any idea. Any other answer if you have anything to ask. And same question we have done same as this question number 156. 156, sorry. Yeah, 156 also same. Moving to question number 256. See, these are 3 CH3 groups. So, CH3 shows inductive effect. But still, this has CO. Oxygen is very electron negative. And it is dragging this lone pair of nitrogen onto it. This way, we know that. So, CO drags lone pair on nitrogen. So, this cannot be strongly basic. This is a weak basic. CH3 groups repels electrons. Yeah, CH3 groups. If I don't like something, I repel it. So don't misguide with this. CH3 is repelling mean it is repelling its own electron. CH3 like this, repelling its own electron. Let's say you have A here towards A. Repelling through the CC bonds towards A. That's true. That is called the inductive effect. So the second statement true. 256, answer 4. Finish. Question number 257. Ethanoyl chloride is this. Reacts with mortar. Readily, true. Lacrimatory. See, we were talking about this. SN reaction. Chloroethane is covalent. And this is chloroethane. That's true. But this is supposed to explain that this chlorine is a good leaving group. This chlorine is highly electronegative. So that plus nature on carbonyl carbon is high. That's why the reaction rate is high. No explanation. 257, answer 2. Suji. එපා දැන් break එක දෙනවා. තව චුට්ටකින් ඊට පස්සේ නාමු. Moving on, 258. Okay, this is the amide salt. By heating this, we can get the amide. By heating carboxylic acid with excess ammonia, we can get this amide salt. What's the connection between this and this? Only difference is this OH2Cl. That's with PCl3. Here, the difference is this. That's again with heating with ammonia. Okay, true. Same reagents, yeah. C to A, D to B, true. Reagent is ammonia. Heating A produces ammonia and C. No, heating A produces this compound. Plus water, B and water. C is CCC. This is weaker acid than this one. Why? Weaker with more inductive effect. Here the chain has 1 carbon, but here chain has 2 carbon, so that more inductive effect comparing to inductive effect of this. Friedel-Crafts acylation, this part. Deforms this with AlCl3. Yeah, acid halides does that. AD correct. 258, answer 4. Moving on. Question number 259. This is again acid halide. Acid halide reacts aqueous part very easily to produce HCl. Then that HCl gets a precipitate with silver nitrate, white precipitate. Organic compounds with ionic chlorine give a white precipitate of silver chloride with aqueous silver nitrate. But remember, this is not ionic, this is covalent. This becomes ionic when reacting with H2O since it is releasing to the medium. So there is no such explanation because this is covalent. So that answer is supposed to be 2. 259, answer 2. Um, 260. Okay, COO ester part was reacting with sodium hydroxide. So this dissociation, so that this part becomes COONA. But from this part you are getting CH3OH, but alcohol doesn't react with sodium hydroxide, just existing as alcohol. 260, answer 4. When I'm asking questions, you guys are not answering. Some of you are not answering correctly. So I'm little disappointing. I want you guys to study at home better. It's not that you are listening this and understanding this. You're supposed to have your own memory. When I'm asking questions, other students, they are just shooting their mouth. They explain everything really nicely. But this group, you are not giving these straightforward, nice answers. You guys need more practice. You guys, out of my Colombo English medium and Ratnapura Sinhala medium, you are the group that not giving me exact answers. Okay, I need more and more practice to be really compatible. You are in good level, but still I'm not happy with your memory. You have to study more, memorize more. Moving on to 261. Lithium aluminium hydride and neutralization. So this is ester, breaks from here. Then CONH2 becomes CH2NH2. But this is phenol OH. This is not reacting with lithium aluminum hydride, just existing as it is. And then the other side, you have HCOOH, formic acid. It is reducing with lithium aluminum hydride to CH3OH. 261, answer 2. Ester reduces by lithium aluminum hydride to produce a mixture of alcohols. Question number 262. Compound B heated with aqueous sodium hydroxide and the cold reaction mixture was neutralized. Okay, sodium hydroxide. We have either amides and esters from here and here and here, and then from here it is breaking. Then add bromine water, it was decolorized. To decolorize bromine water, they are supposed to be this aniline or phenol. This doesn't give such condition. No aniline, no phenol. This again, no. But this has, see, this part is aniline part. B, this part is phenol part. That's possible. See, this is the aniline part. And this is the phenol part. You're supposed to see through this, like, you know, using your third eye, eagle eyes. So CD correct. 263 answer 3. 262 answer 3. Okay, 62 answer 3. Okay. When the compound X having CH2 was treated with excess acetyl chloride, and this is the acetyl chloride CH3COCl, the relative molar mass became 126. Okay, who's reacting with CH3COCl? You should know from your short note who's reacting with acid halides. So they say this is reacting with hydroxyl groups. Which hydroxyl groups? Hydroxyl groups of alcohol or hydroxyl groups of carboxylic acid. So what happens is this chlorine gets away with this hydrogen, making this CO this bond. Then how much new stuff is adding? COCH3. This amount is adding. What is getting away? One of the hydrogen is getting away. So COCH3 molar mass become 43. Molar mass of hydrogen is 1. So net increasement per one molecule, one hydroxyl is 42. But net increasement altogether is 126. How many 42s are in 146? To get that, we have to divide 126 by 42. It's supposed to be, it is 3. It simply means there are supposed to be 3 hydroxyl groups. So 3 of this 42 mean 3 of these groups are joining. For that, there are supposed to be 3 hydroxyl. Okay. Question number 263, answer 3. Anu, didn't you have enough sleep last night? What is it with you with that? Huh? Or you feel very sleepy today? You had any sun medication or something? That's not too late. 6 hours or 5 hours is more than enough. You can be this sleepy. You are like that. You have this sleep medication. Change your attitudes. If you feel like, oh, I had only 5 hours sleep today, I am not feeling good, then you get sleepier. Now you are an adult. Then sleep cannot disturb whatever you do daytime. As an example, these days, couple of days ago, Sir has two. Sir couldn't have enough sleep. Sir came home around 5:30 a.m. because a couple of these guys came to install AC. All people are coming from Colombo. So when they are getting here, they want to do like night and day, then they are leaving. Then AC people, painting people, curtain and everything. So has to wake up, stay up for 2 consecutive days. Even though yesterday when he came, he was around 2 a.m. He's doing everything with masons and all those when they are leaving, so he's coming. But in daytime, he has to work because he's an adult. Have this attitude. You have to work. Even when I was doing my studies, I had lots of days I was just sleeping like 2 hours. But when you get up, you cannot feel this is, you had 2 hours sleep that everybody, this is a good thing to think. Like when you were thinking, I had 2 hours sleep, I wouldn't be okay today. Then you cannot do anything. So no point of staying up if you cannot maintain it in the daytime, isn't it? If you feel sleepy and if you feel really hard in daytime, don't stay up late at night time. So you're saving time, staying up late, but you're not saving time if you cannot use that next day time nicely. Okay, have the sleep just to controllable level. If it is beyond control, if you are being really sleepy now, no point of staying up late night. Moving on to question number 264. What is the major product obtained when the compound above is treated with lithium aluminum hydride? So this is amide part, but this side you have this CO NH2. So this CO become CH2NH2, and this bond breaks so that this CO become CH2OH, and this side is CH3 just OH. It is not given, but I have just written for your practice. 264, answer 3. Okay, let's get this is a break. Yeah, time is 11:03 or 11:05. Let's say 11:05. I'll be back around 11:20. Okay. Get a little break, everybody. And discuss with you guys whatever the things you're supposed to do to go through this path within 6 more months. You have to do everything perfectly. You're going to sit for this exam and you're going to pass this exam. That is the determination of you, everybody. Okay. Tute. Did we do this? Yeah, we did question number 264 and just cut 265. Moving to 266. Organic compound X, when reacted with sodium nitride and LHCl, given N2, that it's not talking about the temperature. When the temperature is lower, N2 comes only with aliphatic, but when the temperature is room temperature or high temperature, both gives N2. Okay. Let's go on, okay? But they say, even they were not given that temperature, they say a phenol is not formed. So it simply means NH2 cannot join onto this benzene. So we have to avoid this and also this. When the organic product formed in this reaction is oxidized under rigorous conditions, organic compound Y is obtained. Y reacted with ethylene glycol, and that is this compound. So this is supposed to be Y then. This is supposed to be Y because it is making this. Terylene is not obtained. So this cannot be this. It simply means you cannot have these two groups here and here in 1 and 4. 1 and 4. This NH2 is also not acceptable. So only remaining possibility is this. Easily you can get the answer. 266, answer 2. Moving on. 267. You don't want to write this? You don't want to copy this one? This is part of unit 14. You guys need this. Did you draw this earlier? No, this is the first time, I guess. Yeah, just draw this. This is unit 14. That terylene is an artificial textile that we're going to do this part for unit 14. So whenever you get unit 14 something, just copy them down because I'm not doing unit 14 tutorial. Number 1, unit 14 is not that important. Number 2, I'm doing it with full papers. Going on. 267. Aniline undergoes to give this compound. That's true. NH2 group activates the benzene ring. That's why easily it is undergoing with this 3 bromine substituted compound. So explanation is there. 267, answer 1. $268 again. This question is exactly same as 265. That's why I'm not doing that. Exactly 265. Just write there 265. Same. Same 265. 269. chemical test between this is aliphatic, this is aromatic aniline, KNO2. So this is giving this CH2Cl, but this is giving diazonium. Through diazonium, we can go on to get this either phenol, yellow color, this beta naphthol red color. We can go on that. 269 answer 4. Even they can give this one because by thermal decomposition, you can get potassium nitrite. Question number 270. Which of the following statements concerning methylamine and aniline? This is aliphatic and aromatic. I'm going with answers. So basicity of methylamine is greater. So its Kb is high because it's more basic. That is the A. Methylamine and aniline can both act as nucleophile because they both has these lone pairs on nitrogen. So only B, C incorrect. You do not need to even read them. A, D only correct. If A is correct, B and C are both incorrect. 270, A, D correct. Answer 4. Question number 271. Again, moving to this acid halide, but this time with amines. They are making substituted amides. So this has delta plus and delta minus. So this lone pairs of nitrogen joining here, chlorine gets away. We did this mechanism in 234th question. So I'm going with the answers. In the reaction, this amine acts as a nucleophile, yeah, not electrophilic. This is nucleophilic substitution. This is the mother molecule. This is not acting as a nucleophile or electrophile. Amine is acting as the RNH2 acting as the nucleophile. A nucleophilic substitution. Nucleophilic substitution. That is the correct explanation. A, D correct. 271 answer 4. Two hundred 72. Reaction of aniline with aqueous nitrous produce phenol. And this is the ethylamine. Ethylamine is this. So that's produce alcohol. But the temperature is 20. They were not talking about lower temperatures to distinguish between the stability. But the second statement explains the stability. This is delocalizing this positive charge within the ring. So plus charge on nitrogen delocalize in benzene ring, therefore stabilizes by resonance effect. But this reason comes with this temperature. They were not talking about the temperature. So no explanation. 272 answer 2. And I'm not going to do the next question again. You can write the answer because it's exactly same. I want you guys to go through second time, third time, fourth time until you feel comfortable and until you can do everything, not looking at my reviewing. Just continuously, you guys need the practice because your memory is not enough. I want you guys to improve more and more to improve your memory. This question we did at 150. You can write the answer. Explanation is there. Question number 150. Same. I'm going to cut these for next year students. Moving on to 274th question. This compound treated with nitrous, this NH2 is converting to N2Cl. This is become N2Cl. To that you are adding phenol with lower temperature, and then this fluorine gets away with this hydrogen to produce this product. This CH3, all right, just let it be there. Who cares that? If you had this CH3 on phenol, then it's problematic. Let's say you have CH3 here on phenol, then can it go through this reaction? No, it is going through para-hydrogen. If para-hydrogen is occupied, you are not getting the product. 274, answer 2. Moving on, 275. An organic compound X reacts with nitrous. So it's supposed to have NH2. Temperature is not mentioned. Let's assume the temperature is room temperature. So this is converting to OH then. Compound Y react with acidified KMnO4 gives Z. So that OH supposed to convert onto some sort of a aldehyde, ketone or carboxylic acid. So this OH has oxidized. Anyway, it's not then tertiary. Compound Z, which came after oxidizing, reacts with acidified alcoholic 2,4-DNP to give orange precipitate. It simply means once you oxidize, it has not gone up to carboxylic acid. If this is become COOH, it is not reacting with 2,4-DNP. Who's going to COOH? Primary alcohol. If you have CH2OH, this is going to COOH. But let's say you have secondary alcohol, COH, C. Then this is converting to ketone. Then this can go with Brady. Okay. So the best answer, this NH is supposed to join onto a carbon, which joins another 2 carbon. Another 2 carbon, 1 and 2. So only possibility is this. If you, by oxidation, a ketone produced. If aldehyde oxidized, it is giving carboxylic acid. Therefore, before ketone, it should be a secondary alcohol. Carbon joined to NH2 should consist 2 more carbon. See, I'm going with number 3. NH2, OH, COCH3, 2,4-DNP, giving this orange precipitate. 275, answer 3. Finish. Oxidation. Aldehyde oxidizing to carboxylic acid. (276). They were not mentioning the temperature, and that's wrong. X was treated with reducing agent tin conch HCl, sodium hydroxide. What is it? NO2, tin conch HCl, sodium hydroxide converting to NH2. Tin conch HCl, sodium hydroxide comes only with NO2, nitrobenzene. Then I isolated, then to that added nitrous acid, then beta naphthol, reddish orange dye. So NH2, HNO2, N2Cl, beta naphthol, this is the dye. So this is supposed to have directly joined NO2, NO2. Can we get this one? Yeah. Let's say to this one, we are adding this mixture. It doesn't do anything, but it can go through the rest of the parts same way. Understood? So that answers are A, B, and D. But answer is 5. No one. Because they were not mentioned the temperature. If they were not mentioned the temperature, it simply means it's supposed to be room temperature. Otherwise, ABD. Anyway, answer 5. Okay. Just mention everything. Question number 277. Ethylamine is this. Does not give a stable diazonium salt with HNO2. Yeah, even the temperature is lower. This is giving alcohol. Because here you have only the inductive effect. That's not enough to, let's say you have N2Cl, that's not enough to control this plus charge. That's unstable. But in aromatic diazonium, plus charge is delocalizing within benzene ring, so that is stable. HNO2 reacts with aromatic amines only. No, it is reacting. It is reacting, but reaction is different with the stability. 277, answer 3. Question number 278, a weird question. You can get the answer very easily. To get this empirical formula, 1.76, 1.08, 0.34, I divide each by its molar masses to get the ratio between CO2, H2O and NH3. 1 CO2, 1 carbon, so same number of moles of carbon, 1 H2O, 2 hydrogen, twice of the hydrogen, 0.12, 1 ammonia, 1 nitrogen, so multiplied by 1, 0.04, 0.12, 0.02. Simplest ratio 2:6:1. But is it this or this or 3 or 4 or 5? That is one problem. They are not saying anything about molecular formula to get the hint. A saturated compound with molecular formula, this is also possible. I am just drawing one example. Okay, you can draw all these hydrogens there, so it's saturated. That's possible. Aliphatic diamine with molecular formula, but we cannot say that's aliphatic diamine. See, not only this, but this also possible. This is diamine. This is diamine, but this is hydrazine. This is not a diamine. So we cannot say the second one is correct. These two are anyway not correct. Data is not sufficient. That is the answer, or they were taken answer as number 1 as well. 278, 105. Just copy down everything you feel like improving your knowledge for our exam. This one, I'm just giving the explanation. If you are still not comfortable, let it go. This is electro. And you guys know electro is very smooth, very easy unit. We're going to do that classified later. If you react this, that you guys know, elements above hydrogen are releasing hydrogen. So AC is supposed to be in the top. BD is supposed to be in the bottom. But C can replace others. So then C is supposed to be in the top. B, D is replacing. So this is the order CA, DB. Just write the answer. If you're not understanding, just leave it. Moving on. 280. PQRST, disonium salt. Okay, this NH2 plus HCl gives this. Then this can we write as like this. So this also has NH2. Remember that. And so that we can get this. And also this is possible. Only two answers. Because here CONH2, COOH plus nitrogen, and this NH2 become OH. Only QT. 280 answer 4. Mm-hmm. 281. This conversion to get this compound NH2, just leaving as it is, addition of bromine water, electrophilic substitution, NH2, sodium nitrate Cl, lower temperature disonium. To that, if you add CuCl, that makes this. Other answers are wrong. Temperature high. CuCl2. This is 10 degrees Celsius. Wrong answers. (281), only B correct answer 5. Right, darling. Stop there. Phenol no SN. sp2 S character high. CO bond gets a double bond nature, and also has the resonance stability. 282. What compound show all these? Liberate CO2 with sodium carbonate. A has COOH, this has ammonium salt, COOH, so ABC. Sodium nitrate and HCl liberates a gas supposed to have NH2 going to OH and N2. So NH2, 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 all four are possible. So all A, B, C, D. Green color solution, oxidizing with potassium dichromate. So this is supposed to have oxidizable alcohols, either primary and secondary. Primary, and primary. Only A, B, and D. This become phenol. Phenol cannot oxidize further. Now let's get the common. A has, B has. That's all. Only A, B correct. 282 answer 1. Moving on. 283 is almost same as 281. Sort of same style, see, when you're having diazonium, +1, nitrogen is more electronegative, -1, so carbon gets a +1. Here hydrogen is more electropositive, so carbon gets a -1. So going from here to here, reduce from +1 to -1, +1 to -1. Who's oxidizing? So the oxidizing one is this acid. +1 to +3. So this acid is supposed to be H3PO2, which can go oxidize very easily. H3PO4 wrong. H3PO4 wrong. And this is giving this orthopara nitrophenol, nitrobenzene, not meta, because once you join one, the other two are joining to orthopara, because this is just bromine. This is again same reason. CBR, HBR. 283 answer. Okay. Here I was checking what's wrong with this one. This is also wrong. See, bromine water, this is supposed to give water para. That's again wrong. Moving on to nitrogen containing amines, okay. Again asking these as simple questions, basicity. C is basic. C is basic, but lone pair delocalizing within benzene ring, so C is least basic. And then D, inductive effect from this side. Then this one comes after D, because still you have the benzene ring here, so it is delocalizing. There is no such thing. And here the inductive effect increases the electron density of nitrogen, but here you have 2CH3 group, more inductive effect. Inductive effect decreases acidity. Inductive effect increases basicity. Let's clear that. Okay. 284 answer 2. $285. Amide is weaker comparing to amine because amide has CO. See, this way amide acidity, basicity decreases. Then they are saying the same thing here. Lone pair on this nitrogen is delocalizing within the benzene ring. See, you get a plus charge. That's why the basicity decreasing. So the second statement is correct, but first statement wrong. If first statement is other way around, then answer become 1. Anyway, here 285, answer 4. Okay, moving on. 286. Extremely easy. Inductive effect increases basicity. This is delocalizing decreases basicity. 286 answer. 287. Which arrangement given below gives the correct increasing order of basicity? Again, oxygen more electronegative, delocalizing the ring in benzene ring. So D is the least. Here no delocalizing, providing electrons by inductive effect. So this is little greater. When you have nitrogen, that's more greater. Even in nitrogen, this is delocalizing. So A is then less. But this is directly providing electrons to nitrogen. So that's the highest. 287, answer 3. Okay, Nadija, Amaya, are you guys understand nicely? Because you didn't answer this, only Saktala answered these acidic basic questions. That's what I want just to make sure you guys understanding nicely, including you, Anu. Moving on, 288. Again asking the base strength. This is amide, then aniline. This is okay, ammonia, but amines are greater because amines have this inductive effect. 288 answer. 289. Which one of the following tests can be used to distinguish between acetamide, this, and ethylamine? Very easily, this strong bases with amide releasing ammonia. Heating with DHCl. This is reacting, but this is not reacting. Acetamide not reacting. But you don't see this observation. 289 answer 2. Last day you are coming to my home, isn't it? That's the beautiful house, better than this. Some are proposing like, we want to do the best for you guys, but some are like, tuition and we want you guys to have this fun of education. 289. Yeah, we done with that. 290. That's again basic strength. Going with the answer. Now, the basicity is decreasing when electron attracting groups are joining. When they are getting electrons away, bring deactivators. Okay, so the greater is supposed to be this one. This is having the activator. And this is the normal. These two supposed to be less, but more or less which one? C or D is the weakest base. Amaya, C or D? Which one is the weaker? D, well done, well done. D is the weakest because very easily dragging electrons away. See? Yeah. 290, answer 3. Weak ring but activator. This is deactivator, but this is meta and this is para. 291. cannot be used to distinguish solid or brown color, oily kind of a liquid, solid, anyway. With bromine water, both gives this white precipitate. Sodium hydroxide, only this is soluble. Both are basic. These two both are basic, so no reaction. And this is this phenol identification test with this one. HNO2 only with aniline. Moist blue litmus only with phenol. Because blue, this is also blue. This is basic blue and this is blue, so no color difference. Only phenol gives color because it's acidic. Moving on, 200. Okay, hang on. Okay, go on. I'll wait. Because I guess this equation is a little new. If you want to write, just put that down. And memorize the color is purple. Purple. Moving on, 292. Aliphatic amine, aromatic amine, soluble in HCl. This is amide insoluble. Yeah, amides are less basic to react with HCl. Amide basicity not enough to react with HCl. Basic strength of amide is lower, not higher. Second statement wrong. 292, answer 3. $293. This is more basic. This is amine, then amide. True. Lone pair of electron on the nitrogen atom of amide is delocalizing. That's why its basicity is less. So that's the explanation. And you can refer with question number 285 as well. 293, answer 1. Wow. Getting closer to 300. That's why I said we're going to do hundreds of questions, like thousands of, more than thousands of questions, tens of thousands of questions. Then how come you are not reaching 100? How come you are not reaching 100? This is what happened to all these, English medium students. Single medium is, let's say, comparing to English medium, but still, Deepna, Karmini, Purna, See? 294. Answer 2. This chlorine gets away with this hydrogen. Anu, what is it with you today? Hmm? What is the medication? Yeah, what is the drug you had taken? You had given something. Oh, maybe that's why. Okay. Okay, this is just a normal, but since we have sodium hydroxide, this is supposed to be ONA because phenol reacts with sodium hydroxide. From one side aniline, the other side ONA. ONA doesn't matter. This reaction can just go same way. 295, answer 1. I want to reach 300. 296, see. This part is just extra. CH2NH2 become CH2OH. Rest of the part is just reaction between diazonium and phenol. Diazonium and phenol. 296, answer 3. Last page of MCQ. I want to finish this, like going on like, don't you feel like these MCQs are really now easier and you feel like we are not doing anything, just writing answers, no challenges? Basic strength again. A, least, because this is dragging electrons away. So more and more electrons dragging away. Then B, just a normal aniline. This is providing electrons, but still lone pair delocalizing it in the ring. D is the greatest, providing electrons and no delocalizing. 297, answer 4. Um, 298. Compound A reacts with sodium carbonate, releasing a gas that turns lime water milky, that is carbon dioxide. It simply means it's supposed to have COOH groups. But still they say A is insoluble in aqueous sodium hydroxide. These two are soluble. These two are soluble. So we have to think of anything else. See, these two guys, if you separate them, this exists as NH2 and HCl. See, think carefully. So then, this is the quaternary ammonium salt that again reacting with sodium carbonate to releasing carbon dioxide. So we have to omit these two. This is no whatsoever carbon reaction with sodium carbonate. These two are dissolved in sodium hydroxide. Then you have to stick to any of these. And here, this one is having one CH3 group here. That doesn't have free NH2. Only free NH2 can go through this disonium thing to make this red dye. So we cannot go with this one. So only possible answer is 5. Are you guys okay? Okay. 298, answer 5. Acidity. This question actually is little unsuccess. Because see, if they are making HCl, that also can dissolve sodium hydroxide, reacting with sodium hydroxide. But still, this part is not reacting with sodium hydroxide. I think that's what they were thinking. In this molecule, you don't have anything to react with sodium hydroxide. (299). Diazonium salt of aromatic amines react with water to form phenol. Yeah. Diazonium with water phenol. Diazonium salt can act as nucleophilic. No. With respect to here, see? Here. With respect to phenol. To this hydrogen. See this hydrogen. It's electrophilic substitution. That's wrong. 299, answer 3. 300 question. See. Benzene diazonium chloride reacts with phenol. Yeah, to give an orange or red, we can consider compound. Yeah. Same thing. Diazonium salt acts as nucleophiles. No. Electrophiles. Question number 300, answer 3. Answer 3. OMG. For me, it's a huge victory. All these 300 questions, we are done. How many days? Not that many. Just 3 days. Shall we move on to structured essay? Did you guys do structured essay? Any of you? Yeah, but few, you did. I don't want to, because I'm doing only up to 12:30. Let's not shorten that time. Very easy questions, first questions, no challenging, so we can just go smoothly. But, you know, Gino is keep saying, I am discriminating Sinhala medium students. I'm always giving the priority to English medium students. Because almost all the time, I'm making this English stuff nicer. The reason is I'm doing everything in English first. Then those are so ruined. Then I had to do second time just to show you guys here. So I'm copying this to Sinhala. So Sinhala is little more better than this. But when it is coming to organic structured essay part, I didn't convert back to this nicer note. But anyway, second part is having these all conversions and everything. So I'm gonna show you guys whenever you feel uneasy. I'm gonna show you guys this Sinhala stuff. Okay, so just let's go together with that. Okay. Anyway, I'm gonna start with this. See, I have this little fund in my novel. Anyway, we're gonna start here. See, not that bad. See this English handwriting. See, this is English numbers. English numbers. And these are Sinhala numbers. Only for this, I guess. But rest of all, English medium are better. Because I had to repeatedly do. But organic, I don't feel like this huge book. I don't want to do this again. Right now, I'm busy. And then we're going to start 26. Then I'm going to start 3 more extra classes. Okay. Anyway, so you guys have this question. Writing the answer with Sinhala one would be the harder. Only for a couple of initial questions, I'll explain the method. Then later, I'm just going to give you guys only the answer. So they were given carbon, hydrogen, and oxygen. So you are writing these percentages. Then you divide each by the molar masses. Then these are the values. Then get the smallest value. Then divide all by smallest value. Then you get 1.35. Then you're going to multiply everything by 3. So then the molecular empirical formula is C3H4O3. Then molar mass is 180. Molar mass of empirical formula is 88. 180 divided by 88 is 2.04. So the molecular formula is twice of that. So this is the molecular formula of these two. We have less than 10 minutes. Yeah, 9 minutes, but still I don't want to waste that time. So we're gonna meet in after 2 more weeks. I don't want you guys to go like that. Anyway, I'm gonna feed this 23rd for 23rd Thursday. I'm gonna feed another recording. Okay. I don't want you guys not to going through this. Okay. Next week, then you are going with the recording. After that week, you are going with recording. Then 30th, you are coming to the class. Okay. I don't want you guys to lose this, whatever this morale that you are having. I guess you guys need to listen my sweet voice once every week. Maybe you guys can blame me later. I don't care that, okay? Because I'm shaping up your precious future beautifully. Then see how easy these questions. That's why that's why I'm trusting, and that's why you want to trust. You know, you guys got this initial knowledge from MCQs, but still these initial questions I can skip, but I'm not skipping. Even you have very little knowledge, even you are very weaker to organic chemistry, but still these are again reminding this simplest stuff. Then when you are going to this modern organic chemistry, you wouldn't feel they are harder. Okay, so second one, this is C. You're going to get double bond to OH. So that's a Bayer's reagent, but they are asking reagent. So the reagent is KMNO4. Alkaline can be a reagent. And then they are asking condition. That is cold. Cold. Then write the answer, cold alkaline KMNO4. Cold alkaline KMNO4. Reagent and condition, underline condition. Otherwise you forget that. You have to provide the condition. Going back. This OH is converted into Br. So number starting from here to here, 2 and 3. 2, 3 dash dibromo pentane. 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 Okay. Then cis-trans isomerism is asking for the next part. These two identical, no. Two identical chlorine, no. Two identical bromine, no. Two chlorine, no. 2 hydrogen, no. But here if you go with this, 1 CH3 group, 1 hydrogen, 1 hydrogen and 1 chlorine. So that's B. So answer is B. And here I'm showing cis trans as well. Cis trans. Next one, 2 identical hydrogen, 2 identical CH3, 2 identical benzenes. But if you go with the last one, 1 CH3, 1 hydrogen, 1 bromine, and 1 chlorine, 4 different. So that's on the N. N. And this is the hydrocarbon structure. This has only hydro. Right. It's long. Let's stop there. Question number 2 is long. Let's stop there. Okay, bye. Take care, everybody. So I'm little like worrying that you were not giving exact answers I was expecting. So work well and have the memory. I think you guys having issues with memory because don't put your time on chemistry on others. Chemistry time, keep the chemistry time. Change your time into, let's say that you are studying like 4 hours chemistry, just leave that 4 hours for chemistry per day, every day. Don't keep that chemistry time to anything else because you guys know I'm reaching 100 marks very easily for you guys. So let me do that. Even if you have issues with other 2 subjects, then you can go to whatever this dream faculty. So never ever give up on chemistry. Okay, bye. Take care, everybody. Good night.